What's up, 7th grade? Mr. Agnos here, and this video is for homework 9-2. Remember in homework 9-1, we were introduced to the idea of an inequality, right? It's a mathematical statement that says two things are not equal, and all of those involved addition or subtraction. Well, today we're going to be looking at inequalities that involve multiplication for division. And there's good news and there's bad news. The good news is that we solve these inequalities exactly the same as you would solve a one-step multiplication or division equation. You're just going to do the opposite, right? If you're multiplying, you're going to divide on both sides. If we're dividing, we're going to multiply on both sides. But there is one huge curveball. There is one huge curveball that only applies to inequalities. So we'll take a look and see what that is. So this is number 2. Excuse me, allergies are off the hook. Over the next 12 months, you have to read more than 48 books. You have to read X books per month. Okay, so X is the number of books per month, 12 is the number of months, and all of that has to be more than 48. So they give you the inequality, all right? They give it right here. There's 12 months, you're reading X books per month. So you multiply that, right? 12 times whatever the number of books per month is. And whatever this turns out to be, it has to be more than, okay? It can't be equal to, it has to be more than. That's why it's just the greater than symbol, 48. So we're going to go ahead and solve this exactly the same way that we would solve the similar equation, right? Since we're multiplying X by 12, we're just going to divide by 12 on both sides. If I multiply and divide by the same number, those cancel. And I get X is greater than 4. All right. This assignment doesn't ask you to graph, but the next ones will. So I'm going to go ahead and create the graph for this anyway. So remember, with inequalities, we actually have an infinite number of answers, right? X could be any number greater than 4. It could be 5, 6, 7, 10, a million, 4.1, right? So we need a way to show that. And so what we do is we just draw a straight line, and I call whatever the number here is, in this case 4, I call it the boundary number, right? And I just put a little tick mark and say, okay, here's 4. And as you move to the right on a number line, numbers get bigger. So this would be 5, this would be 6, and so on. And as you move to the left, numbers get smaller. This would be 3, this would be 2, and so on. And the first thing you're going to do is, okay, do I put an open dot or a closed dot at 4? Well, if you don't have the line underneath, right? If it's not greater than or equal to or less than or equal to, then you have an open circle. The open circle means that 4 is not an answer to this inequality, right? 4 is not greater than 4. They're equal. So in this case, it's an open circle. If I had the line underneath, then it would be a closed circle. But I don't, so it's an open circle. The second question you need to ask yourself is, do I want numbers that are greater than 4 or less than 4? If it's greater, well, you move to the right. And if it's less, you move to the left. So in this case, I want number, and again, if you're unsure, just pick a number. 5, and plug it in here. Is that true? Yeah, 5 is greater than 4. 3, plug it in. Is 3 greater than 4? No, that makes no sense, right? So my arrow is going to go in this direction. So there's my answer, there's my graph. Okay, so again, hopefully this type of problem is pretty straightforward. It's the graphing is relatively new, but solving this is exactly the way you would have solved it last topic. Just do the opposite. All right, let's take a look at number 3, because this is where we're going to start seeing this new curveball that I talked about. All right, I'm gonna rewrite this problem here. It says solve the inequality, and notice that we're dividing by -3 here. I'm not going to do that yet. I'm gonna do a different problem essentially. I'm gonna say m divided by 3 is greater than 3. Okay, so this is a division problem. Some number divided by 3 is greater than 3. So when we're dividing by the same number, we do the opposite, right? We multiply by 3 on both sides. So on the left-hand side, these cancel, and I get m is greater than 9. So any number that is greater than 9, when you divide it by 3, will be greater than 3. And again, if I want to do the graph, 9 is my boundary number. Here's 10, dot, dot, dot. Here's 8, dot, dot, dot. It is not greater than or equal to, so it's going to be an open circle. And I want numbers that are bigger. And again, if you're unsure which direction to go, actually take the number on either side. If I put 8 here, is that true? No, it's not. If I put 10 here, is that true? Yes, it is. So again, my arrow goes to the right. Okay, that's how you would solve a normal one. But for this problem, we are dividing by -3. And when you divide by -3, we have to do something at the end. So I'm going to rewrite this correctly as the correct problem. M divided by -3 is greater than 3. All right, so let's solve this exactly the same way. Okay, let's see what happens. Some number divided by -3. All right, so what I'm going to do here is I am going to multiply both sides by -3, right? I'm going to do the opposite. The shoe's been tied. I'm going to untie the shoe by doing the opposite. All right, on the left-hand side, these cancel. Okay, what I'm about to do is incorrect. It is wrong. Just be clear about that. M is greater. 3 times -3 is -9. All right, so you might think that M being greater than -9 is a solution to this inequality. Let's take a look. Let's graph it and see what happens. Here's my number line. My boundary number is -9. Okay, remember, as you move to the right on a number line from a negative number, right, -8 is actually bigger than -9, and -7, and so on, right? And then 0 would be somewhere over here. -10 would be on the left, -11, and so on. So the numbers are set up differently, and that's what causes the problem here. All right, -9, it is just the greater than symbol. And so we put our arrow going to the right. Okay. Is this true? Is this true? I'm going to add one more number here to make this a little easier, because this is not true. I'm going to put in -6 here. And the reason I'm using -6 is because -6 is evenly divisible by 3. If we did this correctly, then -6 right here should work. Should work when I plug it in to the original inequality. So I'm going to do -6 divided by -3. And if this is all correct, then this should be greater than 3. Uh-oh. What happens when I divide -6 by -3? A negative divided by a negative is positive. 6 divided by 3 is 2. Is 2 greater than 3? No. No, it is not. All right? So this did not work. Something happened. And it has to do with the fact that our numbers here, that we write negative numbers in reverse of the way we write positive numbers. So the rule that we have to follow is that when you multiply or divide by a negative number, you need to flip the inequality symbol. So as soon as I multiply by -3 right here, then when I go to write my answer, originally it's pointing this direction. It's a greater than. I need to change it to a less than symbol. You need to flip the inequality symbol when you multiply or divide by a negative. And I'll write that down here in a second. Let's see how that changes our result. So I gotta delete all this stuff, make some room here. So I'm gonna delete all this. I'm gonna draw my number line again. All right, so here's my number line. My boundary number is still -9. This is -8. This is -7, and so on. -10, -11, and so on. It's still an open circle. All right. But now it says M is less than -9. So my arrow goes this direction. because we flipped it. So let's see how this works. Now again, I'm going to skip to negative 12. And the reason I'm doing that is just because negative 12 is divisible by negative 3. It would still hold true for a negative 11 and negative 10. We would just have a decimal or a fraction. All right, so now I'm going to plug negative 12 in for m. So I do negative 12 divided by negative 3 is greater than 3. Is this true? Right? We're asking a question. Is this true? Is our answer correct? Essentially what we're doing here is we're checking our answer. Negative divided by a negative is positive. 12 divided by 3 is 4. This is true. Winner, winner, chicken dinner. All right. So because the negative numbers get flipped, when you multiply or divide by a negative number, you need to flip your inequality symbol. So you need to write this down. If we were in class, I would have you get out your notebooks. I would have you write this down and we do with several examples. And I'd walk around and I'd check, right? Well, I can't do that now. So it's up to you to make sure that you are writing this down. All right. I don't want that color. When you multiply or divide by a negative number, you flip the inequality symbol. Okay, write this down. Every time you multiply or divide by a negative number, you're going to flip the inequality symbol. So if you need to pause and write this down, go ahead. I am going to delete it. But again, if you need to pause, just pause right now, write it down, and I'm going to do one more example here. So let's just do a really straightforward one. I'm going to do negative 2 times x is greater than 4. Right? So to solve this, since I'm multiplying by negative 2, I would divide by negative 2. Divide by negative 2. These cancel. I get x. I need to flip. I divided by a negative number. I need to flip. So this becomes a less than symbol, and 4 divided by negative 2 is negative 2. Let's take a look at, again, let's graph this and see why we had to flip. Here's my number line. Negative 2 is my boundary number. So this would be negative 1. This would be 0. This would be 1, 2, ... This would be negative 3, negative 4, negative 5, ... All right, we have an open circle at negative 2, and it is less than. So I need numbers in this direction. If I didn't flip it, right? I'm going to do this in red because this is wrong. If I didn't flip it, I would have gotten x is greater than negative 2, right? Well, let's pick a number over here. Let's pick a number over here. Let's pick 2. Okay, so I'm going to use 2, and I'm going to plug it in. So negative 2 times 2 is greater than negative 2, right? This used to be my x, and I just changed it to the 2. Is this true? Well, negative 2 times 2 is negative 4. Is negative 4 greater than negative 2? It isn't, right? Negative numbers are weird like that. It looks like it's bigger, right? But remember, the further you get from 0, the smaller of a number you are. So negative 2 is less than negative 1. And negative 5 is less than negative 2. And negative 1,000,000 is less than all of these, right? So it doesn't work unless you flip the inequality symbol. Okay, so make sure you write that down. Again, essentially, there's nothing different here. I'm almost out of time. There's nothing different from solving division and multiplication equations, except when you multiply or divide by a negative, you got to flip. See you in class.